right, here's the second test prep video, starting off with solving. So let's figure out what x is. And these are inequalities, so we're going to figure out what x is less than or greater than or equal to and all that good stuff. So we've got this or link here, so we have to do one or the other. That's actually not true. We have to solve both of them. So let's go attack that x as we normally would. To undo subtraction, we add. To undo 2 times x or multiplication, we divide, and we get x must remain less than 4. It can be 3.9, it can be 2, it can be 0, okay? Now for this one, we want to get the variable on one side, because see how I circled that? If you can't circle it, it means you need to move stuff. You move stuff by doing the opposite. You have 2 options here. You can move the 2 x's over by subtracting them, or you can move the x over by subtracting. Both work. I am going to subtract x just because, and again, 2x's minus 1x is just 1x. Sometimes kids freak out right here when they get this 0. 0 is a number. So if it was a 2, you'd be just fine. You'd be like, I add 6 to both sides. Well, 0 is a great number to work with in math, right? So x has to be greater than 6. So less than 4 or greater than 6. So what we do for the or ones is we go and we put the 4 on a number line and the 6 on the number line. Because these inequalities don't have the bars under them, we put open dots. We are to remain strictly less than 4. We can't be 4. There's numbers really close to 4 that are less than 4. 3.9999999. So we can get right up to it, but we just have to leave it open. So we go less to the left and greater to the right. Okay, now those or ones, they always head out like this. So if you see an or, your graph better end up going like this, and is like this. So or, and. Also, had these been had the bars under, then we could be equal and we would close these dots right here. So that one's done. The next one's an and, right? Or, and. And I have to divide by -5 to undo -5 times p. The minute you divide by a negative, you have to change the direction of the inequality. Now that's sometimes hard to remember. Let me show you with numbers why that is. So let's suppose I put something that's totally true down. We all know that 10 is a far bigger number than 2. It's greater than 2. But if I were to divide both of these by negative, sorry, my elbow hit it. If I were to divide 10 by -2, I'd get a -5. If I were to divide 2 by -2, I'd get a -1. And we all know -5 is less than -1. So you can see how when we divided by a negative, that we ended up having to reverse that direction. So p has to be less than -3. We'll have an open dot. And on this one, when I divide by a negative, it's not when you have any negative in the problem, it's when you're dividing by a negative. Okay, so let's go graph that. Let's go to -3. And let's go to 2. And I made a mistake on purpose. So remember when I said and goes like this, right? If I were to go to the left of -3 and greater than 2, I would have this. So I know something's off. And what happened is this direction change that I did over here, I also need to do it over here because I divided by a negative. So I should be squeezed between those. There's my and. So make sure you change the direction of that inequality. The next thing up is these absolute value bars. Okay, the absolute value of 7 is 7. The absolute value of -7 is 7. So if I told you the absolute value of x was 7, you'll notice that x could be either 7 or -7. But it is always positive. So when this says the absolute value, is -9, that doesn't make sense because absolute value is a distance. If somebody asked you how far is it from Elk River to Rogers, you wouldn't say -7 miles. And absolute value is a distance from 0. So we can't be a distance of -9. So this is not possible, no solution, that type of an answer. Okay, but had this been a 9, okay, then that means that whatever's in here that you took the absolute value of, it could have been 9, or it could have been a -9. Because if I say, what's the absolute value of 9? You say 9. If I say, what's the absolute value of -9? You say 9. So whatever is trapped in that absolute value bars could be either, and you have to solve both of them. So you get 2 answers. That's kind of interesting because somebody last week, they were doing the book assignment from Mrs. Cedarholm's class, I think, and they said, why is this one so much shorter? And I said, because she knows that you're doing 2 problems for every 1 problem. So, and that's what happens with these absolute value bars is they end up being 2 answers. Because if I said on this number line, where are you 4 from 0? You'd say right here, but I also am right here. So we end up having to do twice as much work. But the very first thing we need to do is realize we need to get x out of these parentheses. We don't start by adding 4 or anything. It's trapped in there, and I have to get rid of the stuff that's in the way. I know Ms. Peterson talks about this as being a prison, that x is that the absolute value bars are bars, like prison bars, and the stuff outside are the guards. And if you're going to break out of prison, because remember we want to get x equals, you better kill off those guards first. And we do it just like we've always done. How have we always removed a subtraction of 10? We add it. This guard is still there. The prison is still intact. But I got rid of the -10, and I'm now at 8. Now, if I were to ask you to read this, you'd say this is 2 times the absolute value. The minute you say that to kill off that guard, you will divide by 2. Now, what's trapped in those parentheses is equal to 4. So make sure you kill off all of the guards before you go on that X attack. All right, now how do I break out of here? Well, whatever's in there had to be 4. Or whatever's in there could have been -4. So that's why I said it's twice as much work, because I have to solve 2 equations. So I'll get 3x is equal to 8. And somebody last week in class of mine, I must have done it wrong. Mine's not nice. It's okay. Just leave it as 8 divided by 3 and move on. So this is +4 plus 4. 3x equals 0. Oh no, I got a 0. I must have, no, you didn't. You just go like this, x equals 0. Now, what that means is when you plug these in, let's try the 0. So let's take this 0 right here and go plug it in to the very original one. So let me unerase, bring the guards back, right? And I will put a 0 in here, and let's see what happens, okay? So if I were to do 0 times 3, I'd get a 0. Minus 4, I'd get a -4. In absolute values, I'd get a 4. So I have 2 times 4, which is 8, minus 10, which is -2. It worked. So, surprise, surprise. All right, I'm on the last 2. Absolute value inequalities. If something is less than 5 from 0, if I say, go give me a number that's less than 5 from 0, you would pick something in here. You wouldn't walk away from the 5s. You want to be less than 5 from 0. And this said less than or equal to. So whatever's in those absolute value bars has to be smashed between 5 and -5. So a less than is a smash it between them. So let's go take that 2x minus 1, smash it between 5 and -5 graphically. This one statement is this one bar where I'm smashed between the 2. And so I'm on the X attack. It's not trapped in parentheses. I simply need to add 1, but you better do it everywhere. So I have a negative 4 on the left, less than or equal to twice x, less than or equal to 6. Again, I'm on the x attack. How do I undo multiplication by 2? Now, even though I'm getting a negative over here, I don't change the direction of the inequality because you have to be dividing by a negative. And I divided by a positive 2. So here is my values for x. And to graph them, remember, we just put them both on there. Solid dots because of the equal to bar, and we are smashed between negative 2 and positive 3 for our values of x. And the last one, if what's in the absolute value bars, if I said stay 4 away from 0, there's a bomb at 0, stay 4 miles away, you could run 4 miles to the right and farther, or to the left of negative 4. But this bomb is killing everything in here. So greater means stay away from 4. And notice I have 2 stay away, not get closer. So what I'm going to do is set up 2 statements. I've got to take and make sure and remember I'm in prison right there, I am greater than 4. Stay away to the right. On the left is where kids sometimes goof up. They want to do greater on both of them, but that would send me this way. Remember, greater's to the right, and I'm going to get killed if I go that way. I need to go to the left. So I need to head on the opposites. So think they need to have different signs. So I need to head out to the left of negative 4, but then I just solve it as I normally would. I add 3, x is going to stay greater than 7. I add 3, x will stay less than a negative 1. So notice my graph for the greater is x open, because there was no equal to bar here. Should have done an example with let's suppose that had been like this. How would this problem change? That would be there, that would be there, that would be there, that would be there. This would have been closed, this would have been closed, and my answers for x are closed at 7 to the right and closed at negative 1 to the left. So again, if these went well, you're going to do really well. If they didn't, I'd run through it again. Why not? Because if it doesn't go well, you have to go through way more time to retake. Then you would have to. Then it would take you just to watch these again preventatively. So anyway, I hope that was helpful. You guys have a good one, and I hope your test goes really, really well. And I really hope I see that at least the academic labbers that you've viewed these. All right. Otherwise, I'm just wasting my time here, right? So. Have a good one, and I shall see you